So last class, just a quick recap, we said that probability density function just recapping some of the equation, is a valid function, valid if it meets a certain criteria, and that criteria is what? The integral from negative infinity to infinity of f of t dt is equal to what? 1. If it meets that criteria, you have a valid density function. We said if you want to find the probability that x is greater than a and less than b, you can find that by integrating the density function from a to b, f of x dx. Sometimes I use t, sometimes x. Doesn't really matter because I'm using x here. If you want to find the probability of x is greater than or equal to a, greater than or equal to a, that's from where? From a to infinity, f of x dx. If you want to find the probability that x is less than or equal to b, that'll be the integral from negative infinity to b, f of x dx. We did two more things after that last time. We did the mean and the standard deviation. I think that's what we did, the mean. We said if you want to find the mean, that's the integral of what? Of x, f of x dx. And if you want to find the variance, which is the mean, the standard deviation squared. I don't want to put the square root there. Okay. Oh, yep. X squared times what? F of x dx minus mu squared. And that's how you can find all these pieces. Here's the problem. Sometimes you do the whole problem, you get the mean, the standard deviation. Let's say we're doing chemistry, and for a certain solution, you go, we found what the mean and the standard deviation for that specific solution. You go to the lab to pull that solution, you go, you know what? I don't need to use that solution, it's too potent now. I want to maybe just lower the concentration. You add water to that. Do you have to go back and redo all the calculations? And the answer is no. So here's what will happen if you have to add to something, multiply, divide, and subtract. What will happen to the mean and the standard deviation? So let's put some rules for that, so you'll have them. If you adding, that's a junk here. So if you know what mu x and sigma x for some event, whatever that story is, and now you want to find not just mu for x, you want for x plus a constant. If you're adding a constant to it, then what we found out, if you do the math on that, you're going to end up with whatever, just take the old average and add to it the constant. And the standard deviation, let's do actually that variance, square, so I don't do a square root. The standard deviation of x plus b, we found out it's the same as the standard deviation squared, or the variance of x, which means the standard deviation will be the same. So from this, you know the standard deviation of x plus b will be the same as the standard deviation of x. That's when you're adding and subtracting. What happens if you have multiplication? I'll give you some examples here. A times x. A times x. Well, this will be, according to our equation, a times mu x. and sigma A times X is equal to the absolute value of A, because sigma will never be negative, the standard deviation will never be negative, times sigma X. Now let's take a few examples. I'll do discrete and I'll do continuous, and I'll give you some of these problems. And I'll even add a third one if I have a combination of both. If I have mu of AX plus B, that's equal A times mu X plus B. The variance of AX plus B equals the variance, sigma squared, of X times A squared, which means the standard deviation sigma absolute value of A times sigma X. Let's see if we can prove some of these. I'll do them with discrete values just to see them. Then we'll go to continuous values. Let's look at the first one, see what the first one is saying to us. Here's what this one is telling me. Let's say I gave a test to a small class of 5 students, and these are their scores: 60, 70, 72, 76, and 80. Let me find the mean for them. To find the mean, this is X, we'll do both, the mean, the standard deviation. $60 squared is what? 3,600. 70 squared is what? 4,900. 72, my head is hurting, so forget it. F18. 72 squared. 5184. $76 squared. 5776. And 80 squared is 6,400. So let's add them. 60 plus 70 plus 72 plus 76 plus 80. When you add them here, is that 358? And the other one, 3,600 plus 4,900 plus 5,184 plus 5,776 plus 6,400. What do we have? 25860. So now what is the mean here? What's the mean of my values? And what's the standard deviation? The mean is going to be 358 divided by how many? 1, 2, 3, 4, 5. And the answer is 71.6. And what's the standard deviation? N times the summation of x squared minus the summation of x, the whole thing squared, over n times n minus 1. N is 5, so it's 5 times 25860 minus 358 squared divided by 5 times 4, which is 20, and take the square root of that number. Where's my square root here? To the power 0.5 is the same as the square root. And I came up with an answer of 1.29816. Let's see what the first rule is telling us here. Let's say these are my test scores. I came in and said, you know what? That test was really hard. See this? The average 71.6. I don't like that. I'm going to give each student 5 points on that test. So now here are the new scores. So this becomes what? 65, 75, 77, 81, and 85. So let's square each one. 65 squared, 4225. 75 squared, 5625. 77 squared, 5929. 81 squared, 6561. And 85 squared is 7225. Let's add both columns. 65 plus 75 plus 77 plus 81 plus 85. 383. And let's look at that. 4225 plus 5625 plus 5929 plus 6561 plus 7225. And that is 29,565. What is the mean? The average is going to be 383 divided by 5. 76.6. The first equation says if you end up adding a number to each value here, guess what? Your average, your mean is going to be whatever the old mean, add to it that number. That's what this equation is telling me. So notice my number was what? 71.6. So instead of redoing this, if I just added the 5 points to this, that's what the new average is going to be. So that's what that equation is telling you. It's also telling me, guess what? My standard deviation here is going to be the same as before. It's not going to change. Let's see if that's true. Just don't waste your time squaring them and adding them. Your standard deviation is going to be 1.29816. Well, let's see if that's true. 5 times 29565 minus 383 squared divided by 20. 5 times 4. N times n minus 1. 5 times 29565 minus 383 squared. Divide that by 20. Here's my number. I'm going to take the square root of that. First, let me change it to a decimal number. I'm going to take the square root of that, so to the power of 0.5, and hit enter. Oh, look at the answer. Is it the same answer? 1.29816. Are these numbers the same? So if you calculate the average for a class, you already have the average and the standard deviation, and you decided to add 5 points to each one, don't kill yourself trying to do it. Your average is going to be whatever the number of points that you added, just add that to it. That's what this one is telling us. If you are adding points to each score, your average is going to stay the same, not stay the same, the old average plus the 5 points, whatever B is. Your standard deviation is going to stay the same. Now, if you multiply each one by a value, And we'll prove that too. We'll use the same numbers just to make my life easy. Use the same numbers here, but we're going to look at the multiplication. If you multiply each score by a number, so here we go, x and x squared, same numbers. This is 60, 70, 72, 76, 80, 3600, 4900, 5184, 5776, 6400. We did the math on this already. We added that. That's 358. And this is 25860. We calculated the mean to be 71.6 and the standard deviation to be what? 1.29816. We did that. Now, what we're saying, what will happen if you multiply each score by, let's say, a 2? Now, according to the equation I put here, it says your average, when you get the new average, is going to be multiplied by that number, and your standard deviation is going to be multiplied by that number. Let's see if that's true. So let's multiply each one by 2 and see if that's, so this is the new x, and this is x squared. So instead of 60, I'm going to multiply by 2. 120, 140, 144, right? What's that, 76? I think 150 something, 152. And 8 times 2 is 16, that's 160. Let's square them. 7,200. 9,800. 10,862, I think. Again, too early for these numbers. Just to make sure, 4,900 times 2 is 9,800, yep. 5184. Let's see, 140 squared. Oh, actually my numbers are wrong here. Everyone is wrong. Because you square it, should be multiplied by 4, not 2. I was trying to multiply the answer by 2 and cheat. Look smart. When you multiply this by 2 and you square it, that's actually multiplication by 4, not by 2. I'll take the easy way out. Too much thinking here. F18, clear it. So 120 squared, 19,600. 140 squared. That's 14. Boy, my eyes are really gone. I have it. 400, right? Next one, 600. Next one, 144 squared. I think it's 28. I can't really tell if it's 28 or 20. 20, thank you. 736. The next one, 152 squared. 2314. 104. The last one, 160 squared. 25600. And let's add the numbers. So here we go, 120 plus 140 plus 144 plus 152 plus 160 equals 716. Let's do the other numbers. 14,400 plus 19,600 plus 2736 plus 23,104 plus 25,600. 103,440. The mean is going to be the 716 divided by the number of value 1, 2, 3, 4, 5. Let's see if it's twice that number. Let's see what's twice 71.6. Is it 143.2? Let's see if that's the case. Let me divide them. 716 divided by 5. 143.2. So it's whatever this actually, when you're multiplying each number by a constant, the mean at the end will be whatever the old mean times that constant. Let's see what the standard deviation is going to be. It is the square root of 5 times 103,440 minus 716 squared divided by 5 times 4, which is 20. Here we go. 5 times 103,440 minus 716 squared, close the parentheses, divided by 20, and take the square root of that, and what I got is 3.8842 according to my equation. What is it? You take the absolute value of A is 2 here. You take this number, multiply it by 2, and that doesn't seem like equal to that number. Did we add something wrong here? Did anyone try it on a different calculator? The same answer?
No.
What'd you get?
I'm gonna have to redo it.
I'm going to put this calculator away. I needed that early when I was doing integration. Well, I brought it for the integration, but for now, I don't need it for that. I'll use this one. That's easier. $120 squared, 14,400. Yep. 140 squared, 19.
The x squared was different.
The x squared was different.
Yeah, the sum of them.
What'd you get? 14,400 plus 19. Let me just add them and see if it matches your number. 2736, 23,104 plus 25,600. 103,440. Unless my numbers are wrong here. 144 squared, 2736, 152 squared,
Yeah, that was different.
23,104,
Yep.
and 160 squared,
25,600.
25,600. So my numbers are good here. My sum is good. 5 times 103,440 minus 716 squared divided by 20. Take the square root.
That's what I got. 1507? Yeah, that's what I got too.
What'd you get?
But I couldn't get the other one to come out the way you got. I couldn't get 1.29816.
Here?
Yeah, when I tried it, I couldn't get that.
Let's see, maybe my number was wrong. 3,600 plus 4,900 plus 5184. I switch calculator. 5776 plus 6400. 25860. So the standard deviation for this will be,
Yeah, because standard deviation for the first one, 7.53, and then that's,
oh, 7.53?
and
No.
then the second one we did was 15.07, so.
Is it?
Yeah.
So let's see, this will be 5 times 25860 minus 358 squared over 5 times 4, which is 20. 5 times 25860 minus 358 squared divided by 20. Take the square, you're right. The square root of that number is not going to be. So the standard deviation is what? 7.53657747257. And let's see what the standard deviation here is. Let's see if it's twice that number, because it should be 2 times that number. 5 times 103,440 minus 716 squared divided by 20, and now take the square root of that number, which is 15.0731549451. Uh-oh. Let me multiply this by 2. 2 times 7.5365 7747257 equals 15.0731549451. So it is true. You take this number, when you're multiplying each number by 2, all you gotta do, take your mean, multiply it by 2, take your standard deviation, multiply it by 2. Your answer is not gonna change. You don't have to go through it and rederive everything.